Alright, so this is the Foundations and Pre-Calculus Math 10 review of the Relations and Functions section of the unit. Apologies for not doing this in class, we ran out of time, but nonetheless I'll try to make it up by putting this video on YouTube. So once again, I hope you can download these questions from the Provincial exam website. They're there. I think I've given you a handout in class, so you should be able to use that as well. Please try these questions first before listening to the video, and once you don't understand, come back and then watch the video. Alright, so here we go. Here's the first one. Once again, you've got that no calculator symbol, so this is going to be on the no calculator portion of the test. This one I think is a combination of stuff from chapter 5 and chapter 7. Chapter 5 because of this function notation, the f of x and g of x. But we remember that, hey, that's just another simple way of saying y. So y equals to 3 and y equals to 5 over 2x plus 1, okay? And because we're talking about the point of intersection, that's the chapter 7 material. This is like a system of equations, right? You see two variables, two equations. So you want to make them the same and solve. Now, once again, no calculator because they're assuming that you can do this without a calculator. Replace the y with 3. And now you're just solving this equation. Simple algebra, I hope. What's our next step? If you said subtract 1, that's great. That's 2. And then this might be a little bit tricky for some of you, but that's okay. We can do this together. To solve for x, we need to now do the opposite of the operation here. So 5 over 2 times x. The opposite would be 2. Divide by x. So once again, you're taking 2 divided by 5 over 2. Once again, no calculator. I hope you remember from grade who knows what, in grade 8 perhaps. Dividing a fraction is the same thing as multiplying by the reciprocal. 2 times 2 is 4, 4/5 is x, and you have to convert that to a decimal. How about 0.8? Okay. The next one says, in which quadrant does the following system contain a solution? So once again, you're going to be doing some graphing and a system of equations, so chapter 6 and chapter 7 here. By the way, for those of you who forgot what it meant by which quadrant, remember the Cartesian coordinate plane can be split into 4 different sections, and each section represents a quadrant. This is called quadrant 1. They use Roman numerals, so this is quadrant 1 in the top right corner. Quadrant 2 is the one in the top left corner. Quadrant 3 is the one in the bottom left corner, and quadrant 4 is the one in the bottom right corner. So how do you do this question, especially without the graphing calculator? Well, my suggestion to you here is to make a quick sketch. Okay? You should be able to make quick sketches of both of these lines. Okay, so I'm going to call this equation number 1. I use a different color for equation number 2. And like I said, this is sketching, so that's part of chapter 6. Alright, so let me just quickly sketch x and y. Let's do the first one. This is in slope-intercept form. So I hope you remember in slope-intercept form what information you get. The 1 represents the y-intercept, and the 2 is the slope. So just really crudely now, I'm going to quickly plot the number 1, and a slope of 2 means you go up 2 for every 1 to the right, put a dot, and notice I've already quickly graphed out my line in blue. Line number 2 is in what they call point slope form, so I hope you can quickly tell me the information in point slope form. If you said the slope is a half, you're correct. And if you said the point on this line is 2, 1, you are correct as well. Reminder to always remember switch the signs to get the coordinates. So what I would do in this case is I'd plot 2, 1, so 2, 1. And then the slope of 1/2 means 1 up, 2 to the right. Okay. You can also go 1 down, 2 to the left. And then I'm going to graph this line, and hopefully now you'll know where they intersect. No calculator required. Okay, determine the solution of the following linear system. Once again, you might be seeing this and you think, oh, this is nice, let's use elimination. I'd probably say no to elimination, let's do substitution since it's just y by itself. So this is chapter 7. I'm going to say let's sub in equation number 1 into equation number 2. So once again, wherever you see y, replace it with whatever is in equation number 1. Go ahead, expand and simplify, and you're going to get something quite interesting. 4x minus 4x is 0x. No more x's. 10 take away 15 is negative 5, and you get this lovely fact. Or is it a fact? Negative 5 equals 0? Don't think so. Not true. Since this is not true, there's no x's, what type of solution do we have? And if you said this is no solution, you are correct. Okay? Now, by the way, if we had something different, let's say you did all the algebra and then in the end you got something like this, 0 equals 0, or perhaps like negative 5 equals negative 5. Are these statements true or false? Yes, they are true. So if they are true, that means the left side equals to the right side, and therefore what type of solution do we have? Yes, this is the infinite solution. Okay, so go back and review chapter 7 if you weren't too sure about this. I believe in my notes I did have questions like this where we did the algebra and we got either 0 over 0 or some other number equals 0, showing the two different weird cases. Let's move on to number 4. Which of the following relations is not a function? Remember the idea of not a function? N-O-T, right? Not. Oh, by the way, I forgot to choose C. Not a function. I hope you remember the idea of a function. Remember, a function is for each input there is only one output. For those of you like dating relationships, this is where you're dating exclusively, okay? Where the guy only dates one girl, not two girls. So, which one of these examples do you have the input or the x value only connecting to one output for every single value? Okay. And if you circled A, this is the one that's not a function, you're correct. And the reason is, here's the number 7. He's dating number 2, but he's cheating with number 9. Bad news. How about this one? Number 5, the altitude of a plane. So this is the altitude. Altitude is just another word for the height. Okay. The height of a plane, is a function of time since takeoff. So we have to identify the dependent variable. Okay, is a function of. In more general terms, we usually say y is a function of x. And when I say y and x, which one is your dependent variable? Dependent, of course, is the one that depends on something that you can actually control, which is the independent variable. So I believe, in this case, the y value is the dependent variable. So whenever you see this idea of is a function of, there's always something before it and something after it. The something before it is the dependent, the something after is the independent, and therefore in this example the dependent variable is altitude. Domain. Domain, of course, is all the possible x values on the graph. Sometimes I'll say it's the shadow that covers the x-axis. So if that's the case, you're thinking, well, it looks like I'm starting here at -4, and I'm covering all this stuff up to 3. But notice solid dot, notice empty dot. So those are clues as to what we can do at the endpoints. If you wrote down this solid dot, right, you want to include 4. Open dot, because you don't want to include 3. That's correct, but this is what we call set notation. That's in the textbook. But then if you look at your answers, this is all in interval notation. Not found in your textbook, but I did cover it with an extra handout in Chapter 5. So please go look at that, Chapter 5 Domain and Range extra handout. Hopefully you remember that this idea of interval notation is this is the leftmost point, this is the rightmost point, and remember square brackets mean you include the values. So that's like your solid dot, and curvy brackets mean you don't include. So that's like your open dot. So in this case, I'm starting at -4, I'm ending at 3, the solid one's at -4, the open one's at -3. How about choosing answer B? Okay. You try 7 then. 7's the range, so very similar to domain, except range means all the possible, you guessed it, y values. And so if I'm starting to shade, I'm thinking, all the way here. And remember, this arrow means it goes on forever and ever and ever. So this goes down forever and ever and ever. Looks like the highest value is 3. The lowest value, well, it goes on forever and ever and ever. So that's what we call negative infinity. By the way, negative infinity is never a square bracket because we really can't bound negative infinity. It just goes on forever and ever and ever. So that's why you always have to use a curvy bracket. And oops, that's not 3. What am I talking about? That's 2. It's late at night. Lesson be learned. Don't do math late at night. You make mistakes. Dumb mistakes, like me. There you go. Okay. By the way, this is all Chapter 5 stuff. Domain, range, Chapter 5, Chapter 5, Chapter 5, Chapter 5. So that was that really hard chapter. Okay, number 8. A bag of caramel candies has a total mass of 180 grams, excluding the mass of the bag, meaning don't take into account the mass of the bag. Really, the mass of the bag is really small anyways. Each candy, though, has a mass of 6 grams. It says a candy is taken out of the bag and eaten. The mass of the remaining candies is plotted versus how many candies are left in the bag. Determine the range. You're like, what is going on? Well, you have to read the context. First of all, can you tell me what the dependent variable would be and the independent variable is going to be? And you can do this by looking at this statement. The mass of the remaining candies is plotted versus how many candies are left in the bag. It's like y as a function of, so here's your y, the mass of the remaining candies, mass, as a function of how many candies are left, number of candies. Okay. Now let's think about it. If the bag was full, what's the mass of the bag? Yeah, the candy's full. Bag's full. All of them are there. What happens when you take out one candy? You lose 6 grams, right? Keep going. You lose another 6. Keep going. You lose another 6. Well, what's at the end? Yeah, it's 0. So hopefully you'll see this. And so on, so on, so on. Okay? If you're talking about the candies in the bag, well, guess what? You started with a whole bunch of candies, and you get less and less and less. The units should be going up by 1, right? So the question is, what's the range for this relation? Range represents what? The x values or the y values? Correct, y values. So we're really looking for all the numbers that describe the mass of the candies. Correct. Okay, don't choose all real numbers because that means it can be in decimal too. Okay, there's no like 1.25 gram candy here. Okay, they're all whole numbers, so no good. Okay. All right, here's these nasty questions from chapter 6. Okay. Determine the equation of a line that passes through this point and it's perpendicular to the line formed by these two other points. Wow. Equation of a line, you should be thinking to yourself, y equals to mx plus b, where m stands for the slope and b is the y-intercept. Okay? But then you see this idea of perpendicular to the line formed by these 2 points. So whenever I see the word perpendicular, I'm thinking, something to do with slopes. And what do we know about perpendicular slopes? You bet, perpendicular slopes have negative reciprocals. So I'm thinking the first thing you should do is calculate the slope of the line containing BC. The slope formula will be given to you on your provincial exam sheet, but of course, if you remember it already, life is so much better. For those in my class, you know the song, sing the song. Slope equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Row, row, row your boat. There you go. 10, take away 9. Negative 7, take away negative 4. Be careful with the negative there. By the way, if I was rushing, this is what I was doing. 10 minus 9 is 1. Negative 7, take away negative 4 is negative 3. So your slope is negative 1 over 3. But what about the slope of the perpendicular then? So therefore, I'll say the slope that is perpendicular. There's my perpendicular sign. Negative reciprocal, that's just 3. Okay. So we're going to take this, stick it in here. We've got our equation, y equals 3x plus b. So you know it's not going to be c or d. But then now is it a or b? How do we know how to find b? Well, we have to figure out b. And notice there's 3 different values, a y, an x, and a b. That's no good for us trying to solve algebra, so we should be able to find a value or 2 different values, meaning we should be able to find an x and a y so that we only have b that's unknown. Do we have a x and a y? Well, an x and a y is a coordinate. So do we have a coordinate on this line? You bet, 6, 0. So let's plug in 0. Let's plug in 6. 3 times 6 is 18. We've got this. Be careful with your algebra. B equals negative 18. So therefore your equation is y equals to 3x minus 18. You should choose A. Okay, number 10. Oh, look at these. Those boat questions, upstream, downstream. We've done a whole bunch of these in class. I suggested to you all, make a chart. Distance, speed, time. You're going with the current. Okay, that's upstream in this case. Oh, sorry, I don't know. I guess it's downstream usually with current. And then against the current on the return trip. So my question to you is, can you fill in all the data in the chart? A boat took 3 hours to travel 24 kilometers with the current. 3 hours, 24 kilometers with the current. Okay, now, we have to be careful here. We're in a boat. The boat has its speed. You can call that x. But so does the river current. And we can call that y. So what happens when you are in a boat and you're traveling with the current? Does your speed increase or decrease? I hope you said increase, because you're going together in the same direction. So the speed should be those 2 speeds added together. Going against the current, we've got the same distance. Time took a little bit longer. And remember, when you're going against the current, something's pushing against you, so your speed should be less. So therefore, let's subtract. Okay. Determine the speed of the current means I want you to solve for y. How can you do this? Well, for those of you who like physics, you've got that DST triangle. There's a few ways you can do this. Distance equals to speed times time. I think that's what a lot of you like, since you don't like fractions. So here we go. With the current, 24 equals to x plus y times 3. And you've got against the current, 24 equals to x minus y times 5. If you don't like fractions, I guess you're distributing, so 24 equals to 3x plus 3y, and then over here you've got 24 equals to 5x minus 5y, and because we are solving for y, may I suggest we try to eliminate x. To eliminate, we're thinking, I need them to be the same. So I'm hearing somebody say multiply the first equation by 5. Go right ahead. Running out of space here, so I'm going to do down there. 24 times 5, that's 120. 3 times 5, 15x. 3 times 5, 15y. Do multiply by 3 in the bottom one. 24 times 3 is 72. 15x minus 15y. And then should we add or subtract? If you want to eliminate x and the coefficients are the same with the same signs, you need to subtract 48. Careful here. 15 take away negative 15, 30y. Y just equals to 48 over 30. And I bet you that is equal to A. You can punch this into your calculator. I'm just too lazy. Right. Moving on. Last one here. By the way, this was chapter 7, okay? Chapter 7. And the one before it, that was chapter 6. Last one here, numeric response. Remember those numeric responses? There are these 4 boxes with the decimal, another 2 boxes with the plus minus in front. So in the end, you're going to have to fill in this. So this is a question I believe that we will do from chapter 7. You're mixing 2 solutions. You've got solution A, which is 30% acidic by volume. Solution B is 70%. And you're going to try to put together an 800 milliliter mixture that is 54% acid by volume. By the way, this is what your science teachers do in chemistry when they mix those chemicals for you guys to use. Okay. That's what they actually do. And guess what? They have to do some math behind it. So the issue here is you've got this solution A, okay? Only 30%. Then you've got solution B, 70%. Really toxic or acidic. So you're trying to make a new solution by taking some of B and some of A so that we have a solution that is 800 mils but only 54% acidic. So because you're taking some of A and some of B, let me just call A the amount from solution A, which is of course 30%. And let's call B the amount from B, and of course that's a 70%. I know, what happened to X and Y? Let's get creative, okay? Now, I'm going to take an amount from A and an amount from B, and what's my total amount going to be in my new mixture? It's 800. So what kind of formula do I create? An amount from A and an amount from B put together gives me 800. Great. There's your first equation. The next part's the tricky part, where it says the mixture has to be 54% acid by volume. Well, I've got percentages here. So the amount from solution A is 30%. So that means I should just take 0.3, I'm writing as a decimal now, of A. Okay, and that tells you how acidic the solution is from A. Well, the amount of acidity from part B is 70%, so whatever amount I have, it's just 0.7 of B. And what's this new mixture supposed to have an acidic measure of? Yeah, 54%. But it's 54% of the entire mixture, right? So what's the entire volume here of the entire mixture? A plus B, right? Or 800. Okay. Now here's where I'm going to bring up my calculator because I want to figure out what 0.54 of 800 is. That's 432. So I guess this is my new equation that I want to use. I've got this one, I've got this one. Let's just use substitution to solve now. I'll solve for B, that's 800 minus A. Okay, so here we go. 0.3A plus 0.7B. And B is my 800 minus A. So I'm using the substitution rule now. Or not rule, but substitution method from chapter 7. Go ahead now and solve. I will distribute. I think that's 560. That's 0.7a. That's 432. 0.3 minus 0.7 is negative 0.4a. 432 minus 560. Help, 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 my brain hurts. Calculator to the rescue. Negative 128. How do you solve for a? Divide both sides by negative 0.4. Help, help, help. Let the calculator do its magic. Oops. I put in too many decimal places. 320. So because the question here just said solve for A, I don't need to waste my time solving for B, although in class I always asked you to solve for both A and B. But because it says how much of solution A is needed, answer to the nearest milliliter, it's already nicely done. So I will just type in or write in 320, and please write the numbers nicely into your bubble sheet on your provincial exam. Now, if you wanted to write down the 2 zeros afterwards, you can. You don't need to. If you wanted to bubble in the plus sign, you can, but you don't need to. Okay? If you leave those blank, they always assume that these are zeros, and they assume that it's positive. However, if your answer was negative, you must bubble in the negative. Alright, I hope this helped. Go ahead and review chapters 5, 6, 7.